Hello, this is another video on university admissions assessments, but it's a little bit different to the ones that I've done previously. I've had quite a few emails coming in about rapid fire multiple choice questions and the time pressure on papers that have such questions. This is an example of one of those papers. This is Natural Sciences Assessment for University of Cambridge 2023. So these are the papers where here we've got an hour and we got 40 rapid fire multiple choice questions. So we'll have 20 maths questions and then 20 questions of your chosen subject, in this case, because it's natural sciences. So be that physics, chemistry or biology. So we got minute and a half a question on average, and this poses a completely different challenge really to what we get in the PAT or the MAT. So PAT or MAT, which are the papers that I deal with the most, they've got multiple choice questions in, and those multiple choice questions are more difficult than the ones that you'll get in things like the NSAA and the NJA. But you got more time to answer them in the PAT and the MAT. Here we've got easier questions, but not very much time. So it's that balance here between accuracy and speed. You want to see you can fit in as many as possible in the hour, but you don't want to be going so fast that you're not being accurate and you're losing marks. So in this video, I'm going to go through the 20 maths questions, which are at the start of this. So that would have half an hour allocated for it. Now, it's a bit awkward with going through these ones. So when I'm doing the MAT or the PAT papers, it's quite often a case of, well, how do you actually solve the question? Here, the issue isn't really how do you solve the question. Given enough time, I'd imagine that you're all looking at it thinking, well, I can answer most of these questions. If I had an hour to do 20 rather than half an hour, you'd probably be fine. So it's not a case that you don't know how to answer them. It's more about the speed. So I've got a bit of a balance to strike on that. So I'm going to go through fairly quickly, but not as quickly as I would do if I was doing the test, because I want to try and point out some things that might be useful as we go through. Now, sadly and unsurprisingly, there isn't a silver bullet for this. There isn't something where I can say to you, right, well, if you do this, then all of a sudden you're going to be answering all 20 questions. That just doesn't really happen. I mean, not surprisingly, the best thing to do is practice, which is what you're already doing. The more practice that you're doing, the quicker you're going to get at these. And that includes going over questions and papers that you've already answered, because a lot of this is process. With these quick questions, you want to be secure and fluent at algebra and number manipulation. And the more fluent you are at algebra and number manipulation, the quicker you're going to get through these. So even if you're repeating questions that you've already done, you're going to be improving your algebra and number manipulation. And it's worth practicing those separately. A lot of the stuff here where you're going to be saving time is actually going to be GCSE level number manipulation and algebra. So it doesn't do any harm to go back to a GCSE textbook, maybe pull up a list of 50 or so algebraic manipulations and just go over them over and over again until you're really, really quick, until you can do it at twice the speed that you're doing it at the moment, that sort of thing. So that's the main sort of stuff. So like I say, I'm going to run through these 20 anyway. I mean, who knows how long it's going to take. I've been doing these sort of things for a while, even though I don't tend to do these papers. So hopefully I'll still be able to get the 20 in half an hour. That doesn't mean to say you should be thinking if you can't get all 20 in half an hour, that means you're no good at it. Most people won't be fitting all the questions in. But if you can pull something out of this that's going to help, that means that instead of getting 10 questions, you're getting 12 questions, then that's a big jump, isn't it? So hopefully some of this is going to help. Right, so with all of that in mind, let's scroll down. Oh, there's a long way to scroll down to the first question. Still going. Right, here we go. Question 1. The surface area of a solid sphere of radius capital R is equal to the total surface area of 10 closed cylinders of radius small r and height 4r. So that's 2 closed ends and then a 2 pi r times 4r. So that's one thing on this. Write down the equation as you're going. Don't double read the question. I don't have to go back to that sentence now because I was just writing it as I was going along. Which of the following is an expression for r? That's what we need to know then in terms of little r. So we can see that. Just be sure you know, for accuracy's point of view, what we're trying to achieve. We need to make capital R the subject. Right, one thing that does save a lot of time, potentially, if you're not already doing it, and it will save time, is don't write too much on your answers. So just manipulate what's already there. So we'll cross out those pi's. Then we can turn that into an r squared. We can turn that into an 8. And then we've got 10r squared times 10. So I've written a lot less there, cancel the 4's on either side. Then we can see the square root is going to give us 5r. The less you're writing, the better. If you were writing out a separate line here, some people might write out 6-7 lines of algebra there, which is going to take a good minute in itself when you don't need to. What matters is circling A, not having a sort of really well laid out formal answer. So that can save a lot of time. Might see a similar thing here. Which of the following statements are correct? So yeah, they've put a lot of the writing out actually in the question here. So we can see, okay, we've got two pairs of fractions dividing each other. So it'd be that times that and that times that. So we can see you've got the same things multiplied there. So that's going to be the same. Again, I haven't written anything out. 53%, so that's just 53 over 100. 84% is 84 over 100. So they're going to be the same. Here we've got some number and some other number. So if we square them both, they're going to be different. So written out as little as possible, and we're in on E. So, but of course the easier questions are generally at the beginning. Right, make X the subject on this. So again, we can see that from the answer. You don't really need to read all of it here. You can see the choice of answers and then what they're presenting us with. This is another one where don't write too much stuff. If your algebra is good, you can do a few steps in your head. So you might jump in on this. A q minus r over s minus x is p minus y. So I've done 2 steps. I've added that to both sides and I've subtracted the y from both sides. So I've come in at that point. Now I can do another 2 steps, as in multiply by that and divide by that. So I've got a q minus r over a p minus y is an s minus x. And now I can see another 2 steps that I'm going to want to do. So I'm going to want to add x on both sides and then subtract the other bit. So I've got x is s minus q minus r over p minus y. So I've written out maybe half as much as I would have written otherwise. And then it comes out at C. So on to question 4. Right, 6 numbers increasing order are these. They're giving us the mean, the median, and they want us to work out the mode. So essentially we want to know what x is on this. So the mean is 12. So we've got what, 51 there and 2. So it's 53. And we want it to add up to 72. So we've got x, well, 2x plus y is 19. And then we've got the median is 7 1/4. So x plus y over 2 is 7 1/4. So x plus y is going to be 14 1/2. Again, this is just nice number manipulation. So x is 4 1/2. Y is 10 if we needed it, but we don't. So again, it's writing out stuff as you're going along and being slick on the numbers. Right, question 5. Right, this is a lot to fit on the screen. I assume we're working out this triangle. Yeah, we want the area of the triangle. We've got a square of side length 1. This might be one, if you know that you're going to struggle to fit everything in, because this looks like it might take a while, this might be a question to skip. But we've got a square side 1. And they've given us ratios of side lengths. Right, so we've got 1 to 2. And yep, 3 to 1, that's the one at the top, and 4 to 1 going over there. So we need to work that out. Right, so let's put these as actual lengths then. So they're going to be over 4 and these will be over 5. And now we've got number manipulation. So we've got 1/3 of 3/4 is 1/4 for that one. We've got 2/5 of 1/4 is 2/20, so that's 1/10 for that one. And we have to average 1/3 and 1/5. So that's 5 over 15 and 3 over 15. So 4 over 15 multiplied by 1. So we've got 1, the area of the square, minus 1/4, minus 1/10, and minus 4 over 15. So we want these over a common denominator, and 60 looks good. So that would be 15 over 60, that would be 6, and that would be 16. So, and again, quicker that you are on, doing your number manipulation, the better. So I've got 60 minus, what's that, 37. So 23 over 60 all in all on that one, which, is it even, oh, it is there down the bottom, F. So I thought I got it wrong for a moment. So that was just being good at manipulating some numbers. On question 6, we want to simplify this. So let's just start factorising then. So we've got x plus 6, x minus 2 on that one. Here, oh, we've got to divide in the middle, so we've got to flip these. So that's an x. Oh, and then we've got a difference of 2 squares. So x plus 6, x minus 6. So that will cancel with that. That will cancel with that. So that's dealt with all of that and all of that. 4x minus 8. So that's 4 times x minus 2, right? So that will cancel, leave a 4x. D. And again, I've not written out very much there. Some people will write out multiple lines down here. So just don't do it unless you really, really have to. Question 7. Given that we've got all of this, what's the value of x? So we need to get what x is. These are all powers of 3, aren't they? So we can just compare the powers. We'll have 6x minus 2. Then we've got minus 2x minus 3. And that's 3 to the 4. So that'd be 6. So we've got 6x minus 12 minus 4x plus 6 is equal to 6. So 2x is 12, x is 6. Okay. The solutions of the equation that are P and Q, P's bigger than Q. What is 3P and 2Q? Right, okay, so P is going to be the positive square root. So we're going to have a minus B is 6 plus, because P is bigger than Q, 36. And then that will be plus 4 times 6. So that's 60 over 6. So that is 1 plus, so root 60, we can only take a 4 out for a 2. So that'd be root 15 over 3. Again, number manipulation stuff. The quicker you can get on that, the better. So that makes Q equal to 1 minus root 15 over 3. So 3P and 2Q. 3P is going to be that, not having to write it again. And 2Q is going to be that. And we add them together, which is 5 plus a third of root 15. So E. See, and again, you can see I'm just saying the same things over and over again, really. Be good at algebraic manipulation, be good with numbers, and don't write too much. Question 9. Last year, the salary of a coach of a football club was 80% the salary of the star player. So we've got a coach, a star player. So we've got 80 to 100. Again, with percentages, you don't need to just keep writing everything in percentages. Just pick some nice numbers and it will still work. At the start of the new year, coach received a 15% increase. So 80 times 1.15 is 80 plus a tenth of 80 plus a 20th of 80. So that's 92. Star players received a 38% increase. Well, that's easy enough off of 100. What percentage of the star player's new salary is the coach's new salary? So we want 92 over 138. So 46 over 69, which is 2/3. D. So yeah, you get this quite often with ratios and with percentages. Like I say, you don't have to keep everything fixed with the numbers that they've given. Just pick out ones that fit with that percentage relationship and then work off of that. It quite often makes the sums easier because you can pick the numbers that you want. Question 10. Two angles of a triangle are 90 degrees and theta. So we've got something like that, where tan theta is root 2, so opposite over adjacent. So we've got something like that. The length of the hypotenuse is 3 root 6. So again, writing it out on the way. Area of the triangle. So the area is going to be a squared root 2 over 2. That's what we're trying to work out. And we've got Pythagoras then. So a squared plus 2a squared, so 3a squared, is going to be 9 times 6. Divide through there. A squared is 18. Put it into here. We get 9 root 2. So you can see the processes though, hopefully. Question 11. Athlete's training session consists of several complete repetitions of a 3-part program. What is the average speed for the session? Right, this might be another one that if I was going to be pushed for time, I'd want to skip because I think this might take a little bit longer than average. So 100 meters at 6 kilometers an hour. So that is a 60th of an hour. So that's 1 minute for the first bit. Then we've got 200 meters at 10 kilometers an hour. Boom, 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 boom. So that's a 50th of an hour. So that'd be 6/5 of a minute. And then we got 100 meters at 20 kilometers an hour. Okay, that's a nice one because it's half the distance at twice the speed. So it would be a quarter of that. So that'd be 3/10 of a minute. So what's our total then? We've got 1 plus 1 1/5 plus 3/10. So that's 2 5/10, which is 2.5 minutes. Now we've got to do the weighted sum of all of this. So we got 1 minute at 6. So 1 times 6 is 6. 6 over 5 times 10 is 12. And then 20 times 3 over 10 is 6. So we got that divided by 2.5. So that's 24 divided by 5 over 2. So 48 over 5, which is what, 9.6. Okay, so yeah, that one did take longer than average, at least for the first 11 questions. I mean, they'll see how difficult they get. Question 12, the line joining the points with coordinates those is perpendicular to this line. What's the value of Q? Okay, so we need the gradient of this line, which is going to be 3/4. Again, you'd have to rearrange everything. We only care about the coefficient of x once we've made y the subject. So 3/4. So we want a minus 4/3 for our gradient of this line. So change in y, q minus 4 minus 2 plus q over change in x. 2q plus 2 minus q. So that's a 2q. That is just a q there. Now let's do some multiplying. So minus 4q minus 8 is going to be 6q minus 18. So 10q is 10. Q is 1. Right, 13. Two objects, x and y, are similar. They're giving us a surface area volume. Right, so this is going back to the classic methods that you probably have something similar to this when you were doing your GCSE questions of this type. So we're laying out here length, area, volume for two objects. So the surface area of y is double that of x. So we've got a and 2a. And the volume of y is 7√2 more than the volume of x. So we've got v plus 7√2. So this is where a nice method, if you say, oh yeah, I've done this loads of times when I was doing my GCSEs, then you can just start filling in the table and working out, you know, we want to get the volume of x. So essentially we want to get v is what we're after here. So v is equal to a root a. And then we've got v plus 7√2 is going to be 2a times root 2a. And that's got an a root a in it. So that is 2√2 times v. Okay, so we're going to have 7√2. And this is where, again, being able to skip a step in your head of the algebra is going to help. And all right, they've got rationalized denominators and all of these. So we're going to have 7√2 times 2√2 is 14 times 2 is 28 plus 7√2. And then we'll have 8 minus 1 is 7. So 4 plus root 2, h. And again, same story. I feel like I'm just repeating myself here. But it's, here we go, tried and tested method. Making sure you know what you're trying to work out. Skipping a few simple steps in simple algebra, because that really is where the time is saved, that you're not having to write this down so many times. You know, being able to go from this line here down to this line in one step without having to write out an intermediate step of the factorized v. You know, to be able to rationalize without having to write out, oh, I'm multiplying by 2√2 plus 1 top and bottom. You know, just seeing this in your head and then being able to put it down, because you're saving an enormous amount of writing time. Question 14. X, y, and z are positive variables. Y is inversely proportional to the square of x. So again, write it down as we go. Y is 20, x is 3. So we'll have 20 times 9, k is 180. Z is directly proportional to x. Z is 1.2, x is 6, so m is going to be a fifth. What is z when y is 80? So when y is 80, we've got x squared is 180 over 80. So get rid of those. 18 over 8 is 2 1/4 for x squared. So that means x is going to be 1.5. Again, be useful at getting through these numbers quite quickly. I mean, that's 9 over 4, 2 1/4. So you could have it that way if you'd written that 18 over 8 as 9 over 4. Clearly, when we're square rooting it, we're getting 3 over 2, 1.5. Anyway, where was I? So what is z then? So it's going to be 3 over 2 times a fifth, so 3 over 10, which is d. Again, quick number manipulation, write out stuff as you're reading it. This equation has got two solutions for A. What's the positive difference between these two solutions? Right, so we've got a weird sort of thing we're trying to work out here. So circle that. Right, this has got lots of powers of 10 in. So I find it useful to deal with powers of 10 first. So let's take that 10 off the bottom, make that one a 5, make that one a 4. So again, I'm not writing out new stuff. I can take an 8 out of here, get rid of all of that and that to leave a 10. And get rid of that on the other side. Then take a 9 from there. So I've now got 9 times 80 is 720. In here, I've got 12a. So I've got that 12a all squared is 720. So come in at that point, square root it, divide by 12. Again, I've not had to rewrite too much. I'm just crossing stuff out. Square root 7. Right, they got root 5s all the way up the answer here. Oh, and that's because 720 is 5 times 144. So that is A is plus or minus root 5. And we want the positive difference between these two solutions. So 2 root 5 is B. Right. So, but yeah, if you've got powers of 10, clearing those up first, it really makes a massive difference, because then you can just see what's left with much simpler algebra rather than having to deal with two things at once. Question 16, for any real number x, the function v of x is defined as this. So we've got 10 to some quadratic power here. What's the smallest value of this? Right, well, powers of 10, I mean, there's only so small that you want to get them as reciprocals, don't you? You know, the more negative we can make this power here, then the smaller the number we're going to get. So we want to get the minimum value of that quadratic. How do you get minimum values of a quadratic, or maximum values? If it was a negative quadratic, we complete the square. So it's going to be x is equal to minus 3 is where we're getting that minimum value. So we've got 9 minus 18 plus 7 is what? Minus 2. So 10 to the minus 2, b. So don't forget some of these things that might have left your mind of what we're doing with quadratics. Yeah, we factorize to find roots, we complete the square in order to find minimum or maximum points. So that's that one. 17, x and y are the end points of a line segment. Okay, so we've got an x, we've got a y. P has got those coordinates. Okay, P lies on the line segment such that it is closer to x than it is to y in a 1:2 ratio. So that's P at minus 8, 5. X to P is that. So to get from X to P, we've gone up 4, so that must be minus 12, and we've gone back 3. Oh, screen's moving. I'm hitting the scroll bit again. A point Q is such that QY is that, right? So we do need Y then. So if we've done that to get from X to P, we're going to have to do it twice to get from P to Y. So that's going to take that down to 0, well, up to 0. And then we've got to take 6 off of that. So that's Y. And Q to Y, we've gone up 7, so Q must be at minus 7, and up 6, minus 7, minus 7. E. I'm going to try to stop hitting the scroll bit on my drawing pad because it keeps moving the screen around. Right, 18. The second term of a linear arithmetic series, A plus D, as the screen moves again, is equal to twice the 8th term, so 2 lots of A plus 7D. The 5th term, A plus 4D, is 9 over 4. What is the 20th term? So we want A plus 19D. That's what we're trying to work out. So from the top one then, we got A plus D, we've got 2A, so we've got 1A there, and then we've got minus 13D. Well, that looks horrible, doesn't it? Put that into here, we've got minus 9D is 9 over 4, so we've got D is minus 1/4. and A is 13 over 4. So here we've got 13 over 4 minus 19 over 4, which is minus 6 over 4 minus 3 over 2. Again, nothing new to point out in that question, just reinforcing the importance of all the things I've said before. Find the maximum value of this. So that is is an easier way for me to read it, at least, where we're going from 0 to 360 degrees. Right, on this one, I mean, you've got a couple of things you could do. You could try some numbers and see what you actually get. I mean, you can see that because they've both got sine x, they're going to be varying in sync. So 2 to the power of sine x, well, sine x is going between minus 1 and 1. So we're going to have a range of a half up to 2. And we're going to have a range of a third up to 3 for what's at the bottom. And they're varying in the same way because they both got sine x rather than some kind of phase shift for one of the powers. So at one end, we're going to have 2/3. At the other end, we're going to have a half divided by a third, as in we're going to have 3 over 2. So it's going to come out as C. If you're not too happy with that, as I say, you could try out some values. So you could say, let's go from 0 to 90 degrees. Yeah, when it's 0, we're getting 2/3. At 90 degrees, we're going to be getting, oh no, not 2/3, we're going to get 1, aren't we? Because we've got 2 to the 0 and 3 to the 0, so we've got 1 over 1. At 90 degrees, we've got 2/3. Now, there's no point doing then 90 to 180 because it's just going to repeat itself. But you could say, let's look at 180 to 270, which is another part of the cyclic nature of sine, which is going to be interesting. So at 180, again, we're getting 1. And then here at 270, this is where we're going to then get 3 over 2. So you can try out some numbers. Okay, you might not be entirely convinced off of those numbers that 3 over 2 is the correct answer, but it's certainly ruled out some options. So, but seeing that these are varying in the same way, getting 3 over 2 isn't that much of a jump. Right, so I've got one question left. 2 bags contain counters which are identical except for colour. Right, the first bag has got 3 blue and 2 yellow. The second bag has got X red, 1 blue and 2 yellow. Counter is picked at random from the first bag and placed in the second bag. The counter is then picked at random, right? Okay, from the second bag. Probability that this counter is yellow is a fifth. What's the probability the counter is red? Right, okay, so we want to get P red from the second bag. That's what we're after. So we've got a 2/5 chance that we're putting yellow in there, which would take us to X to 1 to 3. We've got a 3/5 chance that we're putting blue in there, which would take us X to 2 to 2. Then, so we're getting a 1/5 chance of pulling a yellow. So that 1/5 is going to be, what we got, 3 over 4 plus X, and that's multiplied by 2/5. And then we're going to have 2 over 4 plus X, and that's multiplied by 3/5. Okay, so get rid of all those fifths at the bottom there. So we've got 4 plus X is equal to 12. X is equal to 8. So the probability of red is going to be 8 over 12, which is 2/3, which is E. Okay, so not a bad one to finish on there. So yeah, I haven't really got too much to add really at the end. I mean, you'll see, because I was just saying it again and again and again, what the important things are. I think that writing as little as possible is a big gain, particularly on the algebra questions. So there are a few of them that came up in this where you're just not having to figure out too much. Yeah, I mean, look at 16 here. Knowing how to pick out what the x value is at a minimum of that quadratic saves having to write anything out. If you're spending time actually completing the square on that or doing some kind of differentiation or something, you're just spending time writing out things you don't need. And we had that on a lot of questions. There was a lot of number manipulation. So make sure you're quick at working out these sort of things, this root 720 over 12. Okay, you can take a hint from the root 5s in the answer, but you don't want to be spending a lot of time on those numbers. So practice the sort of things that we saw in, which one was it? It was the one with the, well, this was a nice one. These sort of questions, again, a GCSE sort of question, but a lot of adding up fractions. The better you are at adding up these fractions. It was the one with the coaches' salaries that I quite liked as well. Yeah, because it had this calculation in it. So get used to doing these. Again, just practice them. Just pick some numbers. Think, okay, I'm going to start on 65 and I'm going to give them even if it's a slightly awkward number. Let's say I'm going to give them a 23% increase and then go through. Because if you can do 65 times 1.23 pretty quickly, then they're probably never going to ask you anything that difficult as an actual sum in this paper. So go through being able to work those sort of numbers out. So yeah, same old stuff. Quick algebra, but simple algebra. Quick sums, but simple sums. Don't write out too many things. Question 6, classic example here. How much I could have written out if I kept on writing out new lines for all this algebra. But no, just cross it out as you go along. Let them do the work when they're setting the question. So anyway, that's the 20 questions there in the math section. I'm going to come back in the next video and do the 20 physics questions. Obviously, I'm not going to be doing the biology or the chemistry ones because they're just not my subjects. But I will do the physics ones because there might be a few other pointers in those which we can add to the collection of pointers here. But really, it is just that practice of going through. And if you've set out one of your answers long-winded, like say you were doing that question 6 that I was just looking at. So say you had the full laid out answer and you'd written out 7 lines of algebra or something like that. Go over it multiple times and see how confident you can get and how secure you'd still be in getting the right answer of skipping out the odd line. So go over it a few times, skip out a few lines and just start internalizing it, start getting it into your head, and then you'll find that will build up quite quickly. So there you go. I mean, that aside, you're stuck with it really. I mean, 40 questions in an hour is never going to be easy, so don't feel as though you need to fit all 20 in. It's most people won't be. So, but if you can do some of these things and it moves you up for answering 10 or 11 questions to 13 or 14 questions, then as I say, that's a big jump. So hopefully that's given you some food for thought.